Hey there, in this video, let's talk about Ohm's Law. So in the year 1826, George Simon Ohm, who was then at Technical University Munich in Germany, had established a very simple relationship between the potential difference V and the electric current I. So as per Ohm's law, the current flowing in a conductor is directly proportional to the potential difference across its ends, provided the physical conditions and the temperature of the conductor remain constant. So this portion that I have written in pink is the extra condition that needs to be taken care of. Of course, the current flowing in the conductor is directly proportional to the potential difference. This is what Ohm's law states, that is, the potential difference and the current are directly proportional. This is how we write directly proportional. So as per Ohm's law, we wrote V is directly proportional to I. The direct proportionality sign over here implies that if the potential across the conductor was doubled, the current in the circuit would have been doubled. The same, if the potential was halved, the current also would get halved. We could go ahead and rearrange these terms, removing the proportionality sign and writing V by I is equal to some constant This constant is written as R, R standing for resistance. This can again be written as V is equal to IR. This is the famous equation related to Ohm's law. So if we have a current I equal to 1 ampere, if the current in the circuit is 1 ampere, so if the current I in the circuit is 1 unit, that is 1 ampere, the resistance of the conductor in the circuit would be numerically equal to the potential difference across that conductor. We can then say that the resistance of a conductor is numerically equal to the potential difference across its ends when a unit current flows through it. Let us now have a look at the unit of resistance. We have seen from Ohm's law, the equation can be written as V is equal to IR. The resistance R can be isolated onto the left hand side and can be written as the ratio of the potential difference to the current in the circuit. If I need to find out the unit of R, the unit of R is nothing but the ratio of the unit of potential difference V divided by the unit of current I. We have seen that the unit of potential difference is volt, while the unit of current is ampere. This can be written in short form as volt per ampere or volt ampere inverse. So this is the SI unit of resistance. Instead of using volt per ampere or volt ampere inverse, we use this unit of resistance has been named after Ohm and is represented with the Greek alphabet omega. Omega is written as this. Omega, spelled as OMEGA, omega. We can thus write 1 ohm is equal to 1 volt, capital letter V, 1 volt by 1 ampere. Now let's define what 1 ohm is. So here's the definition of 1 ohm. The resistance of a conductor is said to be 1 ohm when 1 ampere of current flows due to a potential difference of 1 volt across the conductor. So this is how we define 1 ohm. Sometimes in circuits, we might have resistances which are very large. For example, say 2000 ohm, or sometimes we might have 100,000 ohm, 100,000 ohm, etc. Such high resistances can be difficult to write. Hence, we use multiples. Multiples are those such as, if I write 1 kilo ohm, it is nothing but 1 into 10 to the power of 3 ohm. Another frequently used multiple is the mega ohm. 1 mega ohm, represented with a capital M followed by the Greek alphabet omega, is 1 into 10 to the power of 6 ohm. We make use of such multiples in order to represent high resistances. So in this video, we had a look at what Ohm's law was. We defined Ohm's law. We also looked at the unit of resistance, the definition of 1 ohm of resistance, and how we could write down high resistances. So in the next video, we will be looking at how we could verify Ohm's law using a simple circuit.